Thank you very much to all the speakers this morning for their wonderful contributions. I think it gave a really good insight into the hosts, our department, and Inland Waterways International. I had the opportunity of attending the two previous conferences, so it gave me some insight into what was ahead of us for this year, and it gave us a great opportunity. But I think the speeches from both John, Dawn and David this morning give a really good insight into the hosts, what we do, what the Inland Waterways Association of Ireland do and what they contribute to, and how their volunteering supports and delivers so much in Ireland. Also Inland Waterways International, without whom we would have these conferences, so it's fantastic. And again, I think we're very honoured to have had Minister Madigan accept our invite to come along today. It really does give us a sense of appreciation and sense of reassurance that they come along and see the value placed in a conference like this. Without further ado, I'm going to move into the next part of the conference, which is our first keynote speaker. I'd like to invite Catherine Sheridan to our first keynote speaker. Catherine has the pleasant job of taking the first post and delivering our first keynote speech. Catherine is the Manager of Engineering and Maintenance for the New York State Canal Corporation. She has over 28 years' experience in the transportation and maritime industry and is currently the Manager of Engineering and Maintenance for the New York State Canal Corporation. I was fortunate enough to get a quick snapshot view of Catherine's presentation last night. And as Dawn mentioned earlier, all the waterways, from having been and attended a number of different conferences, we all have the same challenges, we all have the same issues and opportunities. And Catherine is going to talk about building resilience, climate change and the waterways, and give us an overview of her observations and the challenges that waterway management organisations have with restoration projects and dealing with issues like climate change and so on. So I'll pass over to you, Catherine. Thank you very much.
Thank you, Sharon. Good morning, Minister Madigan and all Canal friends. I'd like to thank Katrina McGurr and all the organizers at Waterways Ireland and the Inland Waterways Association of Ireland for hosting what I'm confident will be a memorable conference. Also, this presentation would not be possible without Sharon, Katrina, and also Eamon Horgan of Waterways Ireland last night printing my slides and running out of ink. So I apologize if nobody else can print. The New York State Canal Corporation was thrilled to host last year's conference in Syracuse, and we're delighted to be a sponsor again this year. When Katrina approached me about presenting at the opening session, I reflected on the topic I was submitted to discuss, which was climate change, but quickly realized the overarching theme was really change itself. So what is change? Change is exciting. Change is scary. Most of us don't like change. We like to go to our comfort zone. So I think the overriding message is how can we embrace change and really sustain for the future? In order for our inland waterways to remain sustainable, we must continually restore, regenerate, and reimagine. And that means new approaches to waterway management and initiating and embracing change. So what changes have we experienced with New York State's canals? This is by no means an exhaustive list, and many of these drivers are closely related to each other or overlap. This morning, I'd like to focus on three areas the New York State Canal Corporation, or its predecessors, have seen success in embracing or initiating change. We'll start with economics, then briefly discuss risk, and conclude with climate. Economic change has really shaped the history of New York's canals. And walking through that history shows how New York's canals regenerated over the past 200 years. And I think I'd like to say the economics drove the history, but telling the history tells you about the economics. Physically, the Erie Canal was rebuilt twice in its first 100 years to accommodate increased traffic and commerce, starting with Clinton's Ditch to the enlarged canal and to the modern barge canal you see today. The first developments to New York's inland waterways began in 1702 with improvements to natural waterways for navigation. An inland navigation system connecting the Great Lakes to the Hudson River had also been proposed in various forms throughout much of the 18th century, but without any specifics. In 1809, President Thomas Jefferson called the proposal of the Erie Canal a little short of madness. And in early 1817, President James Madison vetoed legislation funding the Erie Canal. Thankfully, the visionaries and proponents of change could not be deterred. In April of 1817, the New York State Legislature authorized funding and construction of the Erie Canal. Construction took 8 years and was completed in 1825. These original canals were 12.2 meters and 12.2 meters wide and 1.2 meters deep. The 584-kilometer long Erie Canal extended from Albany on the Hudson River to Buffalo on Lake Erie. The impact of the Erie Canal was felt across New York State, as communities along its route were formed and flourished through the canal's existence. By far, the greatest impact was to New York City, which then became the busiest port in the United States, surpassing Philadelphia and Boston. The difference in cost to ship goods by water versus road caused this surge in prosperity and also opened markets further west. The rates for shipping by water were 1/10 of the cost to ship by road. The canal also fostered population surge in western New York and opened regions farther west beyond the Great Lakes to settlement. Within a year of its opening, the traffic volume on the original Erie Canal had rendered it obsolete. It was enlarged between 1836 and 1862, expanding the width to 21.3 meters and depth to 2.1 meters. But by the end of the 19th century, this too had become obsolete. So in 1900, then New York State Governor Theodore Roosevelt endorsed the recommendations of his Committee on Canals. And in 1903, a bond act was passed to authorize construction of an improved barge canal. Construction began in 1905 and was completed in 1918. This 1908 image is the construction of Lock 5 on the Erie Canal in Waterford, the Erie Canal's eastern terminus. The navigation channel of the modern barge canal, utilizing existing rivers in many locations across New York in order to avoid digging man-made channels. The dimensions of this modern barge canal in the canalized river sections was 61 meters wide and 3.7 meters deep. A federal Great Lakes Hudson River Waterway Improvement Project was undertaken from 1935 to 1965, deepening the navigation channel from Waterford to Oswego to 4.3 meters, as well as raising overhead bridges to increase clearance. Nearly 80% of today's upstate New York population lives within 40 kilometers of the Erie Canal. All of these expansions were due to economics and the surge in economics across New York State and the United States. None of these expansions would have ever happened if economics didn't drive that change. The current New York State canal system is comprised of 4 canals, the primary leg being the Erie. Of the original lateral canals, only 3 remain in use today. This current system totals 843 kilometers of navigable New York State inland waterway. The 57 locks on the New York State Canal system are 91.4 meters long, 13.3 meters wide, and then additionally there are 19 lift bridges, 116 dams, 610 water impounding structures, 20 reservoirs, and over 193 kilometers of water impounding embankments. We have an extensive feeder system from those reservoirs for water management. The New York State Canal system is also part of a network of waterways which stretches south to Florida, north to Canada, and west to the Great Lakes and Mississippi River. So as you can see, for over 200 years, the New York State Canal system has physically changed, adapting to increased commercial use for the economic benefit of the United States. The peak of commercial shipping occurred in 1951, with over 5.2 million tons of cargo shipped. While there are limited commercial barge operations on the New York State Canal system today, the use has gradually shifted from commercial to recreational. The Canal Recreation Way Commission was created in 1992 to provide a vision for the future through the Canal Recreation Way Plan. In 2000, Congress established through the National Park Service the Erie Canalway National Heritage Corridor and Commission, who developed the Erie Canalway Preservation and Management Plan. This transition to recreational use had its own economic benefits. A 2008 study revealed the direct tourism spending along the New York State Canal system was $380 million annually. Additionally, beyond tourism, the waterway contributes to commercial shipping, irrigation for agricultural and recreation, hydropower generation, public water supplies, and as a water source for industry, research and development, quarries and mining, and steam generation. A 2014 study quantified the non-tourism economic impact of the canal system as $6.3 billion annually. So our budget is about $122 million annually. So the economic impact and benefit for those small dollars is immense. Over the past few decades, discrete segments of the New York State Canalway Trail were added to the New York State Canal system, totaling 587 kilometers and generally following the historic canal's towpath. In 2017, New York State Governor Andrew Cuomo announced the Empire State Trail. This initiative consists of installing wayfinding and informational signage in 2018 and completing the remaining gaps on the Erie and Champlain Canalway trails, as well as the Hudson Valley Greenway Trail by 2020. Those gaps are shown here in dark green and orange. When complete, the Empire State Trail will be a continuous 1,200-kilometer route spanning from New York City to Canada and Buffalo to Albany, creating the longest multi-use state trail in the United States. The addition of the trail to the New York State Canal system has further enhanced the recreational use of the waterway by adjoining water and land users for a synergistic experience. From a historic perspective, in 2014, the New York State Canal system was listed as a National Historic District on the National Register of Historic Places, and last year was designated a National Historic Landmark, recognizing its exceptional value to the United States and its role in shaping the American economy and urban development. The message I'd like to impart about canal history is the waterway regenerated numerous times over a 200-year period to meet the evolving economic needs of New York and the United States. Now, New York's canal's great history hasn't been absent of risk and the need to effectively manage and mitigate that risk. Many changes have contributed to the expanded evaluation of risk for New York's canals. Those include changes in governance and available resources, and the aging of canal infrastructure and advances in technology. Governance-wise, the New York State Canal system has been under the stewardship of various New York State entities, starting with the Canal Board and now the New York Power Authority, all to ensure the canal system would be sustained as an important New York State resource. In fact, as early as 1821, the canal system was protected in the New York State Constitution. With changes in governance comes changes in management approach and resource availability. Additionally, as the costs of doing business and reconstruction of infrastructure have risen, the available resources must be optimized to address the highest risks to serve public safety, system reliability, and corporate reputation. New York State canal infrastructure ranges in age from 100 to 200 years old. The cost of replacement is prohibitive, and we are subject to historic preservation requirements as a result of our National Historic Landmark designation. These lead to the majority of our projects falling in the repair or rehabilitation category. I don't think the engineers in the room would disagree that New York State canal infrastructure is well beyond its original design life. So it's our challenge to prioritize investment and balance needs to keep our system safe and reliable. A part of that effort is timely inspections to discover looming issues and predict deterioration. Our structural inspection frequencies have been automated based on industry standards for asset types, with methodical reductions for structures in poor condition or which are structurally flagged. This allows inspection resources to be dedicated at the proper intervals versus too soon or worse, too late, all to reduce risk. Risk-based inspection is a change from the past practice of applying the same standards to all structures. Well, under the direction of the New York State Department of Transportation, before enterprise asset management even became a buzz phrase, an enterprise asset management system was developed for New York State canal infrastructure assets. Unfortunately, at that time, technology limited the data which could be stored and the analysis which could be done. The system was reimagined while under the direction of the Thruway Authority to take advantage of advances in technology. The Canal Infrastructure Management System was developed to compare the condition of assets, both within similar asset classes or across the entire portfolio. Conditions could be weighted based on risk scoring to prioritize the best use of available funding and rank potential candidates for capital or maintenance work. Don't worry, there won't be a quiz on this later. Now, under the direction of the Power Authority, a second effort to reimagine is taking place. With the migration to Maximo, which is a configurable, off-the-shelf asset management system, we're now adding work history and historical spending, allowing our analysis on all our infrastructure to be more robust. The newest development is the addition of a remotely operated vehicle and drone capability to our structural inspection program. That was my best effort at flying the drone. They don't let me touch it. ROVs can enter spaces too hazardous or confined for inspectors, and the drone is being used with thermal imaging to detect leaks in earthen dams and embankments before those conditions cause a catastrophic failure. All of these changes are assisting our engineers and leaders make more informed, repeatable, and transparent decisions. Finally, with regard to risk, we've embarked on an evaluation of our vessel fleet to retire older equipment which have significant environmental and safety risks and replace them with modern working vessels. 29 obsolete New York State Canal vessels are being repurposed as part of New York State's expansion of 12 artificial reefs. These vessels are being put into service one last time. Their legacy will be represented by enhanced fisheries and diving opportunities for generations to come. To date, 7 vessels have been deployed off the coasts of Long Island, with an additional 6 to be deployed this month. This reimagining of decommissioned vessels is a win for vessel enthusiasts, the environment, and the economy. I'm going to grab a short break here and have some water, or maybe some Irish whiskey, or maybe that's later. So here's a video about the expansion of New York State's artificial reefs with the Canal Corporation as a key partner.
The underwater environment off the coast of Long Island is critical to providing marine habitat for millions of fish, supporting a thriving commercial fishery, as well as amazing recreational diving and fishing opportunities. With more than 500,000 anglers in the Long Island region, the marine economy is a key component of the island's economic vitality, accounting for nearly 15% of gross domestic product. New York has always led the way in protecting our natural resources. This spring, New York State embarked on a major initiative that protects and promotes marine life and grows this economic engine for Long Island. Governor Andrew Cuomo announced that New York State is embarking on the largest development of artificial reefs in state history.
Artificial reefs are about environmental sustainability, it's economic development, it's environmental protection at the same time. It is also an alternative to recycling if you use the right materials. So it's a win-win-win.
This ambitious program is providing vital habitat for fish like cod, blackfish, black sea bass, summer flounder, and lobster. New York's Reef Project is being managed by a multi-agency team comprising the New York State Department of Environmental Conservation, New York Power Authority, and the New York Canal Corporation, New York State Department of Transportation, and the New York State Thruway Authority. We are building at 12 reef sites off the coast of Long Island. This summer, we are developing 6 of the reefs at Rockaway, Hempstead, Fire Island, Moriches, Shinnecock, and Smithtown. Next year, we'll be developing another 6 reefs at Atlantic Beach, McAllister Grounds, Yellow Bar, Kismet, 12 Mile, and Matinacock. We're building artificial reefs using a combination of recycled materials that enhance existing habitats, promote biodiversity, and ensure these marine environments continue to thrive. At each reef site, materials are strategically placed, utilizing the patch reef design, which creates smaller, isolated reef patches that are supported by sandy bottom. Before the structures are deployed, all harmful materials are removed, including oils, asbestos, pesticides, and loose debris. One of the key factors of these reef projects is that they will generate benefits immediately, providing shelter and foraging areas for fish and other marine life.
Reefs that have been put down have been colonized in as little as 2 weeks. Recreational fishermen have been able, and some studies have shown recreational fishermen have been able to take fish off of artificial reefs 2 weeks after their initial deployment.
These benefits will continue to grow over a 10 to 15-year period as the artificial structures become covered by encrusting organisms like barnacles, mussels, and sponges, creating habitats similar to a natural reef. On May 31st, Governor Cuomo led the inaugural event at Shinnecock Reef, where 1,093 tons of materials were deployed, including 885 tons of clean, recycled Tappan Zee Bridge steel trusses, roadway deck panels, and steel piles. 3 out-of-commission Canal vessels, including a 74-foot tugboat and 208 tons of steel construction materials. As this diving footage of the sunken tugboat shows, marine life, such as black sea bass, are already attracted to this new reef habitat. More recently, we deployed materials to create a new habitat at Smithtown Reef in the Long Island Sound. 2 40-foot decommissioned canal vessels and 75 tons of recycled steel pipes were sunk at the 3-acre site that lies 1.6 nautical miles northwest of Stony Brook Harbor entrance. We've begun developing Rockaway Reef, which received its first barge full of recycled Tappan Zee Bridge materials this July. More materials will be deployed there in August and September, including a 100-foot vessel. Today, as part of our ongoing initiative to provide shelter for fish and other marine life off New York shores, we'll be developing Hempstead Reef with a variety of recycled materials, 115-foot decommissioned derrick boat called Ward's Island, another 75-foot derrick boat, 2 large steel power plant turbines, 4 steel bridge trusses, and 2,380 tons of old Tappan Zee Bridge materials. This vast 744-acre reef is situated 3.3 nautical miles south of Jones Beach State Park, and it is 72 feet deep at its deepest point. In June, a barge load of Tappan Zee Bridge materials was deployed at the reef, and 3 more barges of Tappan Zee materials will be deployed between now and September. Development of the Fire Island Reef and Moriches Reef will also take place at the end of the summer. New York is a national leader in taking on critical environmental challenges through funding for the Environmental Protection Fund and Clean Water Infrastructure Act, banning offshore drilling along New York's coastline, and reducing nitrogen discharges into Long Island's Western Bay, as well as leading efforts to combat climate change and strengthen shoreline resiliency. We are committed to building a brighter, more sustainable future for all. Our innovative reef building program is an investment in a stronger, more diverse marine ecosystem that will boost Long Island's recreational, sport fishing, and diving industries, as well as the regional economy.
New York's always led the way. We will lead the way once again. And the proverb that says it all to me always, we did not inherit the earth from our parents. We are borrowing it from our children.
So the reef expansion is a great segue to my final topic, climate change. Regardless of what you may personally believe about climate change, I can tell you that in New York State, our storms are increasing in severity. The recent storms we've had certainly caused us to restore, regenerate, and reimagine. In 2006 and 2011, the New York State Canal system experienced significant infrastructure damage from extreme weather events. Each time, we worked tirelessly to restore navigation and to rebuild using resilient and innovative approaches. In 2006, during the 6-day period from June 25th to June 30th, approximately 25.4 centimeters of rain fell in portions of the Mohawk River Basin. The next few photos show some of the conditions both during and after the storm events. This is a lock on the Erie Canal. Notice the lock house is flooded and the water is above the lock walls. You can sort of make out the chamber where the lock looks depressed where the water is very turbulent, towards the right of the screen. This is at Lock 9 on the Erie Canal. Again, the lock house is flooded and the water is above the lock chamber walls. And here's a video taken by a contractor who was actively working on a rehabilitation project adjacent to this lock on a movable dam structure at Lock 10 in Cranesville. The floodwaters devastated their staging and work areas, and as a result of the flooding, they lost an entire year on a 3-year project, making it 4-year. You'll see a container with tools and other small equipment just being tossed around, and in the background, you'll see the knuckle of an excavator, which is completely submerged.
That might be Jay. Oh yeah, there goes the barrel.
Yeah, that's our oil barrel going down.
That's great.
So this was sometime later, also at Lock 10. The lock house is actually still on its foundation, but has been scoured and was tipped over. This building was replaced with a new building with its foundation installed on piles. There's another photo at Lock 10 following the receding waters. It's just devastation. This is at Lock 15 on the Erie Canal. The roof in the foreground was from the maintenance shed that was completely washed away, and the vessel in the background was washed up onto the roadway. It required 2 large cranes to put it back in the water. This vessel weighs approximately 75 tons. It was moored on the approach wall to the lock, which is over 60 meters from this road. So here's some of the restoration photos for that 2006 event. So 5 years later, on August 28th, 2011, Hurricane Irene wreaked havoc on the Mohawk River Valley and the Erie Canal. During recovery operations from the hurricane, 7 days later on September 4th, a tornado directly hit Lock 10, further damaging the lock structure. And in the photo on the right, you can see the walls, which are lined with steel plates. The steel was ripped from the chamber walls during that tornado. We also had a small fire in a facility further west, and at that point we were wondering if the locusts were going to come. So we thought recovery at that point was achievable in a really short time frame. And then Tropical Storm Lee impacted the same watershed on September 7th, which was 3 days after the tornado, delivering another 25.4 centimeters of rain over a 10-day period. This is the movable dam, which is adjacent to Lock 8 on the Erie Canal. The Mohawk River has breached around the dam and is, at this point, completely uncontrolled. This was at the height of the peak of the water. This is the upstream side of movable dam at Lock 9. The lock is in the foreground, and I think you can just see the tops of the flagpoles and the flags on the left side of the photo. So you can kind of get an impression of how high the water really was. This is Lock 10. The building you see in the foreground, where you can just see the roof and the tops of the windows and maybe the top of the number 10, that's a 2-story building. So this is the north end of the movable dam at Lock 9. The photo on the left is following the initial hurricane that came through, and you can see the roadway approach to the bridge is intact. Then in the photo on the right, after the second storm 9 days later, the roadway approach was washed away. The bridge is still standing, and the lock is still standing, but all of the surrounding area is gone. Here's some additional photos at Lock 9. Thankfully, at this bridge, the abutment, wing walls, and pier were on piles. And you can see they're completely exposed. You're never supposed to see a picture like this. They're always supposed to be underground, never to be seen again. We also had extensive damage to utilities during the two events. This is from Lock 10. Much of the superstructure of the dam was destroyed from the forces exerted by the debris field on the chains, which we'll talk about that later. You can see the bent floor beams in spans 1 and 2. And for perspective, this is what the floor beams are supposed to look like. So here's the bent condition, and this was the repaired condition after we were done. This is again Lock 10. The lock house and concrete spillway you see were rebuilt after the 2006 storms. And if you remember the tilted building a few photos ago, I mentioned that was rebuilt on piles to withstand future storms. Well, it did, except nothing else around it did. This is Lock 11. You can see the dam uprights have over-rotated right through the dam. That's not the normal condition. The normal condition is vertical. And here's an aerial view of Lock 11, where historic Guy Park Manor was partially destroyed. And on the right, you can see the foundation of the washed-away lock house. So we had quite a bit of restoration to do after 2011. So here's a summary of the $85 million of canal infrastructure damages. The key bullet here is 126 kilometers of the Erie Canal were closed for 84 days. Our navigation season is approximately 150 days, so being closed for more than half of that period is a significant impact to the economy in upstate New York. The public expects the New York State canal system to be open, safe, and reliable. Through significant efforts by canal staff and external contractors, the waterway was reopened in record time following these devastating events. But we needed to do better. The status quo was no longer acceptable, and we needed to look for opportunities for improvement. A significant change in operational thinking was needed to lessen the impacts of these events, which had now become the new normal. Canal leadership looked at two areas which, with significant investment and wholesale changes to operations, could provide long-term flood mitigation to not only benefit the canal system, but also adjacent property owners and communities. We decided water levels needed to be proactively lowered in advance of a predicted storm, and that we needed better predictive capability. So sort of a little bit of a history lesson on what a movable dam is and how it operates. 8 movable dams are located on the Mohawk River in Montgomery and Schenectady counties in New York State. They're located adjacent to locks and are seasonally installed to impound water for navigation. They're about a 100-plus-year-old design modeled after dams which were existing at that time in Czechoslovakia. This photo shows the navigation season configuration. In the winter, they are completely removed from the river at the end of the navigation season, returning the waterway to a free flow, wow, I put that in here, free flow river condition during the winter months. This photo shows the dam with no obstructions. So they operate by lowering uprights, which are attached to the truss-style superstructure and hang vertically into the water. 2 sets of gates slide down pairs of uprights to impound the water. The uprights and gates are raised and lowered by a movable winch, which we call a mule, which ride on a set of rails similar to a train on the truss. And all of that is done through raising and lowering chains. Traditionally, the lower gates were installed at the beginning of the season and left in place until their removal at the end of the season. So this animation shows how the components work together. So this is a flyover of the dam at Lock 14 on the Erie Canal. I want to thank Bergman Associates for putting this together. So here you get a cutaway of the dam. You'll see the upper gates go up, the lower gates go up, and the water levels equalized. Now the uprights are being pulled as pairs. So that's essentially how the dam goes from navigation season to non-navigation season. So during those flood events, the uprights essentially became large trash racks and held back significant quantities of debris. You can see the debris lodged between the uprights in these photos. That debris artificially raised the upstream water levels, which exacerbated the flooding condition. Additionally, the debris pulled on the upright chains, in turn pulling on the floor beams that you saw bent a few slides ago. So in order to mitigate these conditions, the Canal Corporation decided the gates and uprights would need to be removed on demand during the navigation season. We had anecdotal evidence existed indicating that they couldn't be removed and that they would be damaged during that operation. So we tried to validate those anecdotes, and we did a controlled test, and we broke the dam. We put it back together. We learned a lot from the experience. Our structural engineers put a lot of gauges on there and analyzed all that data to come up with how can we meet our goals of taking this out mid-season. So a $28 million FEMA mitigation grant was approved to replace the uprights using more robust steel, replacing gate rollers with low-friction bearings, and replacing mule components. We also added lighting for safer nighttime operation. Operational procedures were developed to initiate the upright removal with a forecast of a 10-year or greater storm event. The hydraulic modeling that was done indicated that a reduction of flood levels would be as much as 2.3 meters by doing this operation. They were implemented in 2012 and also used again in 13 and 17. They were successful in mitigating damage and flooding. So when we talk about change, this is a huge success story. Longtime employees were so against this. They said it couldn't be done. Once we validated it and did it 2 or 3 times, and they still weren't convinced after the first, they are now our proponents, and they're suggesting further improvements. We also had an uphill battle with FEMA, as their rules for mitigation grants didn't address systems. They would fix components that were broken, but not systems. It took us a year to convince FEMA that this proposal had benefit to these communities in this area. We finally succeeded and gained their approval and funding. We've also proven to our neighbors that we'll take preemptive action to make sure our system in their communities remains safe. The moral of this story is we can't be afraid to change because we've always done it that way. We must push the envelope, break things, engineer solutions, and argue against bureaucracy to ultimately make our waterways safer and more reliable. So here's a great view of Lock 10 today, taken from our new drone. The movable dam uprights and mules have been strengthened, and also the park-like surroundings near the lock have been restored. The other area we decided needed change was the need for better forecasting. We received another $8.5 million FEMA grant for a proposal to develop and implement a canal flood warning and optimization system. This effort would add additional stream and stage and precipitation gauges, filling the existing gaps, and developing a web-based tool to provide situational awareness for the canal system. This tool includes 3 river basins covering over 33,000 square kilometers in upstate New York. The tool includes early warning of flood inundation areas and peak flood timing. In this next video, you'll see the inundation from Hurricane Irene, which occurred in 2011, which we're using to validate and revise our models. So you'll see the areas get inundated in light blue as the storm progressed. And then you'll see them recede after the peak flow went through. So in addition to real-time awareness, the system has forecasting components to allow emergency managers to proactively protect their communities. This will assist in managing evacuations if necessary by not only showing which areas need evacuation and which don't, but also showing what access routes may become usable or reusable over the duration of an event. what facilities may become inaccessible or reaccessible, such as schools, hospitals, or shelters, and what the timing is associated with any of those actions. So at the beginning of this presentation on the timeline, you may have noticed a topic I didn't discuss. At last year's conference, we announced a $2.5 million competition to reimagine the canals. This is an exciting time for New York's canals as we embark on yet another transformation. I'm going to keep you in suspense, so make sure you attend the closing session of this conference later this week when my colleague Sheridan will have more detail about that competition. The stewards of the New York State Canal System have always been focused on sustainability. The staff at the New York State Canal Corporation all deserve my sincerest thanks. They are the folks who work hard to make a difference. As you can see, the New York State Canal System is no stranger to change, or this conference's theme, restore, regenerate, and reimagine. Those themes have permeated our culture and way of doing business for over 200 years. We don't intend to stop, and we look forward to the challenges and changes ahead. We at New York State Canals, and I hope all of you, will evolve and adapt so our future can continue to enjoy our waterways for generations to come. Thank you, and enjoy the rest of the conference.
Thank you very much, Catherine. I don't know about all of you, but that certainly blew me away. That was a fantastic presentation. And I think, Catherine, covering all the themes of our conference, right the way through from the economic value of the waterways through to the historical significance of our waterways, and certainly the results of extreme weather conditions and what they can do. And I hope most of us as waterway management organisations don't have to experience the extreme weather conditions and the results of those and the financial impact I think that has on waterway management organisations. Even the animation of the movable dams, for me as a non-technical engineer, I could even understand what was happening. So I hope many of you learnt so much from Catherine's presentation. I am going to end this session right now. We're going to break for 20 minutes. I want everybody to go out and have tea, coffee outside. There's 3 or 4 stations for teas and coffees outside. We're breaking for 20 minutes. The next 2 speakers will commence at 11 a.m. back here in this room. Can I just say questions will take place at the end of the 3 sessions of our keynote speakers. Again, the coffee break has been sponsored by New York State Canal Corporation. So again, there will be a video playing and you can see all of our exhibitors outside. So please take your time, have your tea and coffee and come back in here refreshed and ready for the next 2 speakers. Thank you.
2. 1, 2, 2. Mic check. 1, 2.